Maths Made Easy, 9th Standard, Part 1. Hello friends, today we will only focus on all geometrical figures and their properties. Remember, even simple basic properties that you have studied in lower standards are equally important. Otherwise you can get stuck up while solving problems. I have tried to incorporate all the points required for solving the problems. Revise them and you will find drastic improvement in your ability to solve any problem easily. In triangle ABC, 1. Angle A plus angle B plus angle C is equal to 180 degrees. 2. Exterior angle C is equal to angle A plus angle B. 3. In isosceles triangle, if AB is equal to AC, then angle B is equal to angle C. To prove this, draw AM perpendicular to BC. You can now prove that triangles ABM and ACM are congruent by RHS rule. 4. In equilateral triangle AB is equal to AC equal to BC and angle A is equal to angle B equal to angle C equal to 60 degrees. 5. In any triangle, length of any two sides is greater than third side. 6. Rules of congruency of triangles SSS, SAS, AAS, and RHS. Very often you will have to use these rules for proving congruency of triangles. Rules are simple. If you make some practice, you will become master in no time. 7. If AM is perpendicular bisector of BC, then AB is equal to AC. Remember, this can be proved by proving congruency of triangles ABM and ACM. 8. Circumcenter C. Point of intersection of bisectors of three sides of a triangle is called circumcenter of the triangle. Note it is the center of the circle which passes through three vertices of a triangle. Note CM, CN, are perpendicular to sides AB, BC, and CA and also bisects them. Also note that CA, CB, and CC are three radii of the circle. Hence, they are equal. You have to make use of these points for solving the problems. 9. If BI is angle bisector of angle B, then IM equals IN, where IM is perpendicular to AB and IN is perpendicular to BC. Note this can be proved by congruency of triangles IBM and IBN by AAS rule. In center, point of intersection of three angle bisectors is called in center. Here IM, AN, and IO are perpendicular to sides AB, BC, and CA. IM, AN, and IO are all equal as already seen above. Therefore, circle drawn with I as center and touches three sides of the triangle and radius equal to IM, IN, or IO. Remember that any of these points can be used to solve the problem. 11. Median. Line joining vertice of a triangle to midpoint of opposite side is called median. 12. Centroid. Point of intersection of three medians is called centroid of a triangle. 13. Centroid G divides median in the ratio of 2:1, referring to above figure AG as to GM is equal to 2:1. When it is said that it is a median, you should note that BM is equal to MC and so on. Also AG as to GM is 2:1, is important information for solving the problem. 14. Orthocenter is a point of intersection of three heights of a triangle. That is, AP is perpendicular to BC, CQ is perpendicular to AB, and BR is perpendicular to AC. This information can be used for proving congruency of triangles. 15. Area of a triangle is equal to half of base multiplied by height. Therefore, height of a triangle can be useful in finding area of a triangle or for comparing areas of triangles. 16. Area of a triangle can be worked out using Heron's formulae if length of all three sides of a triangle is known. Please note the formulae carefully to avoid mistakes. Note that here S is half of sum of all three sides of a triangle. 17. Midpoint theorem. In a triangle ABC, if M and N are midpoints of AB and AC respectively, then line MN is parallel to BC and MN is equal in length to half of BC. Note that this property is required to be used many a times to solve the problems. 18. As per Pythagoras' theorem, in right-angled triangle, square of hypotenuse is equal to sum of squares of remaining two sides of a triangle. For example, in triangle ABC shown above, side opposite angle A is marked as A, side opposite angle B is marked as B, and side opposite angle C is marked as C. Hence, as per Pythagoras' theorem, square of C equals square of a square of B. This theorem is required to be used very often in solving problems. 19. Each area of a quadrilateral ABCD is equal to area of upper triangle ABD and area of lower triangle BCD. Therefore, area is equal to half of BD multiplied by height AM plus half BD multiplied by height CN. In some problems, you have to draw lines parallel to BD through A and C, and perpendicular distance H is used in place of sum of AM and CN. 20. If diagonals of quadrilateral are perpendicular to each other, then area of quadrilateral can also be expressed as half of BD multiplied by AC. 21. Area of circle is equal to pi into square of radius r. Area half circle is equal to half of pi into square of radius r, and area of quadrant, that is, area of 1/4 of a circle, is 1/4 of pi multiplied by square of radius r. 22. Perimeter of a circle is equal to 2 pi multiplied by radius r, and that of half circle is equal to pi multiplied by radius r plus 2 times r, and perimeter of a quadrant is equal to half of pi multiplied by r plus 2 times r. 23. Area of sector. Sector is an area bounded by two radii. An arc of a circle is shown in the figure. This area is equal to theta divided by 360 degrees and multiplied by pi into square of r. 24. Area of segment. Segment is an area bounded by arc and chord of a circle as shown in the figure. This area is equal to area of sector minus area of triangle OAB as shown in the figure. It is equal to theta upon 360 degrees multiplied by pi into square of radius r minus half of square of radius into sine theta. 25. Area between two concentric circles. It is equal to area of outer circle minus area of inner circle. Therefore, area is equal to pi into difference in square of outer radius r and square of inner radius r as shown in the figure. 26 parallel lines and an intersecting line. When two or more parallel lines are cut by an intersecting line, various angles are formed. These angles have definite relations with each other. It is necessary to remember their names and their relations, which you will need to quote while using these properties while solving problems. Alternate angles are the angles on either sides of intersecting line and between two parallel lines or both outside parallel lines. For example, angle 3 is equal to angle 5, angle 4 is equal to angle 6, and angle 2 equal to angle 8, and so on. Supplementary angles are the angles on the same side of intersecting line and either both in between two parallel lines or both outside them. For example, angle 4 plus angle 5 is equal to 180 degrees, and so on. Linear pair are two angles formed by a line touching or intersecting a straight line. Hence, sum of these two angles is 180 degrees. Even though it is a simple basic property, many times you will need to use it for solving the problems. Otherwise, you will get stuck up. Accordingly, angle 1 plus angle 2 is equal to 180 degrees. Also, angle 2 plus angle 3 and also angle 3 plus angle 4 are 180 degrees. Corresponding angles are the angles on same side of intersecting line and both on upper side of parallel lines or both on lower side of parallel lines. For example, angle 1 is equal to angle 5. Angle 4 is equal to angle 8 and angle 2 is equal to angle 6, and so on. Perpendicular distance between parallel lines is same throughout. This is very simple basic property. But remember, if you forget to use this property when required, you cannot solve the problem. 27. If intersecting line makes equal intercepts between three or more parallel lines, then any other intersecting line make equal intercepts. Corollary of above. If intersecting line makes intercepts in the ratio of 2:1 or any other ratio, then any other intersecting line makes intercepts in the same ratio. 28. Variant of intercept theorem. In a triangle ABC, centroid G divides median AM in the ratio of 2:1. If we draw AQ perpendicular to BC, then line parallel to BC drawn through G will divide line AQ in the same ratio. That is 2:1. Not convinced? Please wait. Draw a line parallel to BC through A. Now apply intercept theorem. Remember, you can use this method for solving the problem. 30. Perpendicular to chord from center of a circle bisects the chord. Referring to figure, it can be easily proved that triangles OAM and OBM are congruent by RHS rule. Remember all these properties. This will lead you to 100% success. Equal chords are equidistant from center. Equidistant means perpendicular to the chords are equal. We have seen that perpendicular to the chords bisect the chords. Referring to figure, we have to prove that OM is equal to 1. For this, draw OA and CA. You can prove that triangles OAM and OCN are congruent by RHS rule. Therefore, OM is equal to 1. Remember all these points carefully so that you can make use of these points for solving the problems. 32. Equal arcs or equal chords subtend equal angles at the center. Referring to the figure, it can be easily proved that triangle OAB and triangle OCD are congruent by SSS rule. Here there are 2 radii in each triangle and chords are equal. But it is important to keep this property in mind. 33. Angle subtended by arc of circle at the circumference is half the angle subtended at center. Referring to figure, angle BAC is half of angle BOC. To prove this, join AO and extend it to R. Now, using external angle theorem, we can prove this as shown in the figure. (34) Angle subtended by equal arcs or equal chords at the circumference are equal. To prove this, we know that angles subtended by equal chords at the center are equal. But angle subtended by a chord at the circumference is half the angle subtended by the same chord at the center. Therefore, angles subtended by equal chords at the circumference are equal. 35. Trigonometry refers to properties of right-angled triangles. Table given shows the meaning of sine, cosine, and tan of any angle. Also, reciprocals of the same are given in the table. Remember them very well. It is going to be a base for all advanced formula of trigonometry. This table shows actual numerical values of sines, cosines, and tangents for different angles. By heart them very well. These values will have to be used in solving problems. Accordingly, sin 0 degree is 0. Sin 30 degrees is 1/2. Sin 45 degree is 1/2. Sin 60 degrees is √3/2 and sin 90 degrees is 1. Remember these values very well. After all, it forms the basis of trigonometry, and in all advanced level trigonometry you will need it. Also note values of cos of any angle given in the table. Simple method to remember them is to keep in mind that cosine, any angle, equals sine, 90 minus that angle. Also note that tan of any angle is equal to sine/cosine of that angle. Thank you for watching this video. In case you find it difficult to solve any problem, please write it in your comment. I will give you the guidance for solving the problem. Please like and subscribe to the channel to get more interesting videos. Thank you.